Hey guys, this is John, and today I'm going to be doing a quick tier list on machine learning slash AI books and, what I think that you should and shouldn't read. This is a pretty ironic video given that the next one's probably going to be about how much I dislike AI and just generally. So, anyways, not that I even really want to talk about this, but I always get asked because I don't know, apparently the most knowledgeable person in my village on the topic, perhaps. So, anyways, but I haven't even read that many books, you can see. Now, on the right side, because I think what a lot of people don't understand is that most of like AI and machine learning is actually math, not like really programming. And if you know the math, translating that over to programming is simpler than you'd realize. So, oh, right. And if you like this video, please like and subscribe and share. Yeah, so, anyways, these books are kind of what I'd recommend as the most streamlined versions of what you do to get through all of the required math you'd like need for a majority of machine learning books. I guess I'll say a couple things too. Like, this isn't all the stuff that I've read. This is the stuff that comes to mind when I'm like building this quick list. I guess there's some other books too on the math side of things though that I haven't included in here. Like, for example, there's obviously Serge Lang's algebra textbooks. There's the lengthy like math for computer science PDF online. It's like 2,200 pages, and it goes over all kinds of things, like I think up to about algebraic topology. It does have some nonlinear optimization, etc. So very dense though. So, anyways, you can see that basically I'd recommend you go through them is in this order. So, starting off with how to prove it, and it doesn't have to be Thomas's calculus, but it should be something like Calc 1 to 3. You go through these at the same rate, or sorry, at the same pacing. Then do a linear algebra book like the one by Friedberg, Insel, and Spence, and then all of statistics. Now, you can obviously swap out the linear algebra book for a number of books. You can obviously swap out calculus by Thomas for any number of books, and you swap out how to prove it for any number of books, but you should have all of the baseline knowledge to get through it in this order. And then when you go and tackle all of statistics, which is kind of really, I guess, where you want to be in the sequence, you should be able to go through it. Yeah. Okay, cool. So now let's actually get to the list. Now you can see that I did kind of change the formatting here to like basically just, okay, is it detailed and useful, or missing one of those qualities, right? Because that's kind of the main point of reading these books anyways, is does it contain useful information, and is that information detailed? And I think that useful is more important than detailed here, so there. So let's just kind of go through this. So dirty data processing for machine learning, this is not useful but detailed. So when I was reading this initially, I figured it was going to help me basically clean up messy data. So what you may or may not understand about like training models, for example, is that most of your time is going to be spent on cleaning up the data, collecting the data, etc. And a lot of value can be had in being able to go through dirty data very quickly and cleaning it up so that you can train the models on it. Anyways, so I just thought this book could be more useful than it was for that. This is mostly a collection of research articles. So yeah, actually on that line too, large language models, a deep dive, I felt was also kind of lacking in utility. It is more detailed than hands-on large language models, which I'll just go over next. But it's also just a collection of, again, like research, which or not like a collection of research, but like it reads like disconnected facts, I guess. Um, yeah, so I just didn't find it very useful. Now, you may or may not believe it's like, you know, actually, yeah, I'm gonna put it in detailed and useful. Actually, this one's surprisingly very good on the topic. It does go through a review basically of all the different components, the ways you can kind of switch them out. And it is just for language models, by the way, but walks through the history of them, walks through the different changes that have been made to language models over time, um, how different things can be mixed together to, like, say, giving tips for prompt engineering and walking through, say, the different iterations of prompt engineering that have occurred over time and what people are kind of looking at now, right? And so in terms of like utility, it's really high actually if you're working with language models. um, I would say. And I think it's pretty detailed actually, so I think I'm gonna put it up here. uh, I might change that later though, because some of these other books are really good too. Okay, this one's an easy one. I'm gonna put it in neither. Uh, yeah. Yeah, it speaks for itself. I think I talked about this in another video. Basically, just, cookbooks all have the same problem, it seems, after I've been through, like, a few of them. Just disconnected facts, like, here, type this. Like, I don't need to go through a book for that. I can look that up anywhere. Okay, build a large language model from scratch. You know, see, this is another. This is really good too. It's a little bit disconnected. I Man, maybe I should change these tiers, but okay, like this has to go in detailed and useful too. It's pretty. Well, maybe it's not even okay. Okay, I might change the criteria later, but these are pretty good books though. These are both focused primarily on the architecture and on the coding side of things. So how do you code them, which I did say is pretty self-explanatory with the math, but these contain virtually no math. So that's why I'm kind of confused if I do really want to put them in detail, but yeah, but very highly applicable. Yeah. Okay, mathematics for machine learning. I'm gonna put in uh, yeah, I'm gonna put in neither. Kind of sad, I guess. But its main problem is that it's trying to like rush through all the math, so I feel like it doesn't really kind of teach you very much about anything, and it's kind of a slog, right? So I think aside from presenting what you need to know in math to go and do machine learning, it's not that useful. And in comparison to, say, going through other textbooks, it's not that detailed either, and it's probably not even sufficiently detailed in itself to solve a lot of the problems if this is your only material. Okay. Let's come back to these two. Introduction to statistical learning. I think it's useful, not quite detailed though. Actually, its only problem, to be honest, the only problem with this one is that the questions are not quantitative at all. So the reason why I take an issue with that is because most of that kind of conceptual side of statistics gets covered in like any undergrad. I think aside from that, because it does showcase some of the quantitative aspects, but I think the problem is that if you don't go through questions on them, it's hard to really kind of link across the formulae and understand the, really the principles of the math. I put in useful, not detailed. I'm going to move build large language models down as well. I do think this is probably a better book in the topic. Okay, designing machine learning systems. That's another easy one. We're going to put in either. A lot of people kind of recommend stuff like this. I think this is only useful for people that already understand all the other aspects of the technology or don't actually use it or make anything with it. Yeah, because otherwise I'm just not really sure what you're supposed to get out of reading something like this. Like, you're not going to read this and make any models. I don't think so. Yeah. Okay. Math and architectures for deep learning. This is probably detailed, useful. It's a great balance between the math and the coding side of things. Like, if you were going to use one reference, it probably should just be this. There are some downsides to it, though. It doesn't really have, say, like questions, I don't think. And the math isn't very, very in-depth. With that said, you could probably even go through this book just having, again, I wouldn't really recommend you read this because this is a slog to get through if you don't have any background. At least if you're going through all the questions, right? You could probably even do this without if you just have some statistics background at university, you could probably get through this pretty easily. You're some kind of graduate. Okay, now with these two, they're definitely very good books. They're probably just going up here. They're pretty similar. These are both Bishop's books. They do have distinctions between the two that I'll just kind of quickly describe. The first few chapters are, I think, the exact same. They're just going over probability theory basically, and some statistics, right? So, including some other stuff too. I think in the first chapter it talks about basic classification models, for example, and so on, right? So more or less, the first few chapters are basically the same, and then there's obviously a much greater focus on deep learning or neural networks in this book, but neural networks have gained more recent focus due to their use in language models in particular, and other things like Q-learning methods. But neural networks are not, all machine learning is, and that's what this book goes over. There's one chapter, I believe, on neural networks in this book. Other than that, it's dedicated to, traditional machine learning methods like separations and classifications, etc. There is something that's worth noting about this too, though, which is that I don't think that the background described in the book, which is needing calculus alone, is enough to get through them. I think it says calculus and linear algebra, because if I recall correctly, I believe that the Calc 1 to 3 material doesn't go over things like separation of variables or change of variables, one of the two, whatever it's called. That stuff that gets covered in a course on differential equations. So you would need more math than, not much, but just because a lot of the questions, especially in this book, do rely on understanding change of variables, and the appendix isn't going to give you enough information about it. So, yeah. Okay, cool. So that's all I'm going to say about that today. Probably, like I said, next week I'm probably just going to make a video on how much this all sucks. Yeah, but here you go. Here's your tier list. This is what the internet loves. Okay. Bye.